Hi, let's continue with normal distributions. And this lesson, we will focus on using normal distribution table in reverse. If you want to know how to find out the probability using the normal distribution table, you may refer to my previous video. All right. So let's have a quick revisions here. When we talk about normal distributions, the curve has these features. It is a bell-shaped curve and it is symmetrical. So in the middle is the mean. And it goes on to the positive side to infinity, to negative side to infinity as well. And the area under the curve is the probability. So the total area must be equals to 1. All right. And we have to talk about standardizations. So whenever you are looking for the probability, you must first carry out this working, the standardizations. Then you are getting the z-score, which is a normal distribution with the mean 0 and the variance 1. Okay, 0. Hence, we will have like 3 standard deviations from the mean. And then we can refer to the normal distribution table to find the probability. Okay, so now we will look at the table, but we will use it in reverse. Let's see example 1. Part A. So when you are given X as a normal distribution, capital N stands for normal distribution with the mean. The first value must be the mean, 32. The second value is the variance, 25. All right. So now we are trying to find out the probability of the X less than a small letter A, and the probability is given 0.6194. So find the value of A. So when you have a question like this, where you are given the probability, this kind of questions, you are going to use the table in reverse. So how do we do that? Now I'm going to show you the steps. First, you must always start to standardize it. So A must minus the mean divided by the standard deviations. So don't forget, it's the standard deviations. So you must square root the variance. Okay, so now I'm going to sketch the bell-shaped curve. So there are two things I'm looking at when I'm sketching the bell-shaped curve. First thing, I'm referring to the directions. So since it is less than, so it is moving towards the left. Then second thing, I'm looking at the probability to see whether it is more than 0.5 or less than 0.5. So in this case, it's more than 0.5. So combine these two informations, we can conclude that after we standardize it, the value of z-score must be on the right-hand side, which is the A minus 32 divided by 5 here. And the probability is the area under the curve and moves towards the left, right? So this is the probability 6194. Okay. Now we refer to the table. Okay. Don't forget, when we use the table, see, this diagram sketch here is telling you this table is constructed in such a way that the z-score, we always refer to the positive value here, and the area will always go to the left. And since this bell-shaped curve is symmetrical and the area under the curve is probability, total must be 1. All right. Hence, the left-hand side must be 0.5. The right-hand side also must be 0.5. Okay, now, when we have the probability of 0.6194, and you look at the sketch I am getting here, is exactly the same as the table given. So we are trying to look for the probability 0.6194. And then we are not able to get 6194. We only managed to see 0.6179. All right, another value 6217, which is greater than 6194. So we always have to take the smaller value, so that when we refer to the last column here, see the add here, we're going to add the number so that it is going to be 0.6194. And hence, we have to add the 15. And always remember, the number on the third column will always be the last digit, right? So in this case, the 15 will be the last 2 digits, which means 6179 plus with the 15. That means it has to be 0.0015. And you can see this is going to give you 6194. Okay, and the corresponding z-score value would be 0.3, 0, and 4. Okay, that means if you refer to the bell-shaped curve again, when the z-score is 0.3, 0, and 4, the area towards the left, which is the probability, is 0.6194. Correct? Hence, A minus 32 divided by 5 equals to 0.304. And that is how we will be able to find out the value of A. Multiplied by 5, and then plus 32. Okay, so do the calculations. Hence, A equals to 33.52. All right, so that is how we use the table in reverse. Now we look at the example B. So now this is another normal distribution. The variable y, it follows normal as well. The mean is 10. The variance is not given, right? Represented by a sigma. So y is greater than 14.7 and the probability is 0.1464. Okay. So first, we always got to do standardization. Minus the mean divided by standard deviations, which is the sigma here. All right, like I said, I will refer to these two things. First is the directions. So since it is greater than, means we are looking at the area towards the right. Second, we look at the probability to see whether it is greater than 0.5 or less than 0.5. And in this case, less than 0.5. So we combine these two information, we will be able to sketch the bell-shaped curve, the standardized one, 0 in the middle, so greater than towards the right, and the area is less than 0.5. So which means the z-score must be a value somewhere here, which is a smaller area, that to give you a probability of 0.1464. And that is a z-score, 14.7 minus 10, which is 4.7, divided by sigma. Okay, so what are we going to do? If you refer back to this diagram here again, you can tell it's the opposite area given in this question. All right. So in order to refer to the table, you are not able to get it done directly. So what must you do first? You just have to simply look for the probability by 1 minus 0.1464. What do we want? We want to get the area over here. Okay, so maybe I put in red color. So to find out this area, we take 1 minus 0.1464. And what is 1464? So the probability is 0.8536. Okay, now we get to read from the table in reverse. So look for the 0.8536. And most likely you are not getting 8536. 8536, right? We only managed to get 8531. So in order to become 8536, we need to add another 5. Hence, the corresponding z-score value will be 1.05 and 2. All right. So don't forget about the 1.0 here. The z-score 1.052. Okay, so we have found it 1.052. Okay. So again, sketch the same bell-shaped curve to illustrate that when the is too near to 0. So put it further away here. 1.052. So this smaller region here gives you a probability of 0.1464. At the same time, the big area here is 0.8536. Okay, then hence 4.7 over sigma must be equals to 1.052. And that is how we get the sigma value. Taking 4.7 divided by 1.052. 4.4676. So we round off to 3 significant, 4.47. Okay.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.